Hey guys, hope everybody's doing all right. Jumping into our next lesson for our online learning, we're going to be talking about graphing sinusoids. That's that word here. All right, and what that means is just the shape of the graph of sine and cosine. Okay, so in this lesson, we're going to be talking about graphing sine and cosine, and what the shape looks like is a wave. Okay, so the graphs of both of these are actually pretty similar. It's really just the points that you're starting at. That's the main difference between the two. Okay. So what we're going to do is we're going to first look at sine, okay? We're going to look at it from 0 to 2 pi, okay? So if you guys have your unit circle, you should definitely get that out or refer to it as I come up with these values, okay? So the ones that are really easy to do, right, are going to be the ones that, if you're talking about on the unit circle, the ones that are on the axis, right? So we're talking about 0, we're talking about pi over 2, pi, 3 pi over 2, and 2 pi, right? Those are the really easy ones because they're either 0 or 1, right? So that's what we're going to do for the graph here. Okay, so I have 0, I have pi over 2, I have pi, 3 pi over 2, and then 2 pi. Okay. I'm going to go up to 1 or negative 1. Okay, so as I'm starting at x equals 0, right, sine of 0 is just 0. Okay, so I'm going to put a point there. Okay. Sine of pi over 2 is positive 1. All right, so that point goes up here. Okay, we got sine of 1 pi, which is just 0. Sine of 3 pi over 2 is negative 1. So I'm going to go down here. And then sine of 2 pi, if you notice the pattern, is also 0. Okay, so what you're going to do when you graph sine now is you just connect the points with smooth curves, okay? So you're going to go up, and then you come back down some more, and then go back up to 2 pi, okay? So that is one wavelength of the sine graph from 0 to 2 pi, okay? Now, I don't want you to just limit it between 0 and 2 pi because sine can go on forever and towards infinity and negative infinity. So what you want to do is draw little arrows right after those points because that's going to tell you that the graph is going to keep going. Okay. So after 2 pi, right, if you guys look at the values that we did over there on the right, the values start to repeat again, okay? And that's going to just keep doing that. The pattern keeps repeating, you know, as you go in both directions. So we're going to say that the domain for any sine graph is always all real numbers, okay? And then the range for this graph goes from negative 1 to positive 1, okay? Now, there's a couple things that you have to be able to kind of figure out from any sine or cosine graph, okay? And the first thing is what's called amplitude, the amplitude of the graph, okay? And that is how high and low the graph goes above or below the axis. Okay, So your x-axis here is what's called your principal axis. All right, all the points stem from, using that axis, kind of like it's right in the middle, right? It's right in the middle of the highest point and the lowest point. Okay, so the amplitude represents how high or how low the graph goes above or below that axis, or that principal axis. Okay, so how high it goes above the axis, okay, or how low it goes below the axis. Okay, so that distance represents the amplitude. Okay, so if you guys look at, the highest point that I have here is 1, and the lowest point that I have here is -1, okay? So the amplitude in this case, in this example, is +1, okay? So the amplitude is 1, okay? Now, if I went up to, say, +2 and down to -2, my amplitude would be 2. If I went up to +10 down to -10, my amplitude would be 10. Okay, so it's all based off of how high and how low you go above the axis. Okay. Now, the other thing that you're going to have to be able to find is what's called the period. Okay. Now, the period represents how long it takes the graph to repeat the cycle, okay? Or you can also say it's the length of one cycle of the graph. All right, so like I talked about before, like for sine and cosine, it's really the graph just keeps repeating, okay? So I started at 0 and I ended at 2 pi, but once I got to 2 pi, that pattern is going to start repeating itself again, okay? So the period here is, again, the length of one of these cycles, one of the sine cycles, okay? So that is the period, okay? How long does it take for one cycle to complete? Okay, so the cycle, again, is going to be how it's going to go. Start at the axis. It's going to go to the high point, then the axis again, the low point, and then the axis for the third time. Okay, that's one full cycle. Okay, now I know, there might be, you might be asking, okay, do we have to do those points all the time? Do we have to figure out all those values all the time? Well, because this graph, repeats a lot, what you're going to be doing is repeating the values a lot of times, okay? So there's this kind of acronym that I use a lot for the sine graph, which is called SAHALA. All right, so if you can remember that acronym, that'll help you come up with the values pretty quickly, okay? Now, what this stands for, right? The S represents, because you're talking about sine, okay? Now, the A represents the axis. H is the high point. A, again, is the axis. L is the low point. And then A, again, is the axis, okay? So if you follow that pattern, that will give you all of your points that you need, okay? So this, again, if I start here at 0, that's my axis. Then I go H, that's the high point. Then I go axis, low point, axis, right? SAHALA, okay? So if you guys can remember that little acronym, it'll help you a lot as you're going through these graphs, okay? Okay, so we're going to do the same thing for cosine. Okay, I'm going to start at 0. And I'm going to do the axis angles again. just because they're easy. All right, so if I'm doing cosine of 0, that's going to be 1. Cosine of pi over 2, that's 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi is 1. Okay, so again, this is going to have a cycle that is going to repeat itself as you work your way through it. Okay, so I'm going to start at 0, so 0, 1, so that's your high point, and then pi over 2, 0, axis, pi, -1, that's your low point, 3 pi over 2, 0, axis, and then 2 pi, high point. Okay, so for cosine, you have the acronym CHALA. Okay, so that's high, axis, low, axis, high. Okay, so that should help you kind of come up with the graph every time for cosine. All right, so the cosine graph looks like so. All right. Now, what would be the amplitude here, right? So the amplitude, again, how high and how low do you go above the principal axis here, okay? So again, you're going up 1 above the axis, and then you're also going down 1, okay? So again, the amplitude here is going to be +1, right? And then how long does it take for the cycle to repeat? Okay, so that again is going to be 2 pi. All right, so sine and cosine have that in common. They have the same amplitude and they have the same period. If you're just talking about the regular parent functions. Okay, so we have the domain is again going to be all real numbers, and then the range again is the same thing, -1 to 1. Okay, so as you guys work through this, right, remember your acronyms. They're, I know they might sound a little silly, but I think it helps you out a lot. So you have Sahala for sine, and then Chala for cosine. All right, so like I have here at the bottom of the page, you have a wave pattern every 2 pi radians. All right, they're called periodic functions. That's why we had to figure out the period. All right, they keep repeating themselves over a length of 2 pi. All right, and we're going to call that the cycle. Okay, so typically what I'm going to ask you guys to do is you're going to have to graph like 2 or 3 cycles of the function. Okay, so what I just did for sine and cosine is I graphed 1 cycle. Okay, so if I wanted to do another 2 or 3 of them, I would just repeat the pattern. I would just have to label my x-axis to come up with the x values. And like I said, these functions, their graphs are called sinusoids, just because they represent a wave pattern. Okay. Now at the top of the next page, these are just standard transformations. Okay, kind of standard form for sine and cosine. So we've done this since day one. All these values here, A, B, C, and D, right? They're gonna transform your function. And they work the same way that like we've been doing since chapter 1. Okay. So if you look at the bullet points here, right, it says that the A term is always going to represent the amplitude of the wave. Okay, and again, that's the distance from the principal axis. Okay, so depending on what function you have, all right, that's going to change what your amplitude is. Okay, so what I'm going to do now is I'm going to jump down to number 3. Right, and I'm gonna actually put these in on Desmos so you guys can kind of see what I'm talking about here. So as you can see, you got sine of x, 2 sine of x, 4 sine of x, half sine of x. Okay, so for each of these, right, our amplitude is going to be a little bit different. Okay, so I'm going to pull up Desmos. Okay, and what I'm going to do is just put in sine of x. Okay, now over here I'm just going to label this a little bit. So negative 2 pi to 2 pi. And I'm going to go up by pi over 2. And then we'll say negative 1.5 to 1.5. Okay. Now the reason I'm doing a little bit more than, well, actually, you know what? I'm going to change this. Say we'll do negative 5 to 5, just so that we see the difference. Okay. All right. So if you guys like zoom this out, right? See how the pattern keeps repeating itself every 2 pi. Right, kind of goes on forever in both directions. All right, so we're just going to focus on just between 0 and 2 pi right now. Okay, so right now I have just sine of x. Right, so what if I did 2 sine of x? So 2 sine of x. Okay. So you see how the graph looks pretty much the same, right? But the only thing that's changing is the amplitude, right? That's the distance. Like you see how pi over 2 goes up to positive 2, and then 3 pi over 2 goes down to negative 2, okay? So it's just stretching the graph, all right, by a value of 2, all right? So the values are going to stay the same, except at your high and your low point, okay? But the period does not change, right? The period is still from 0 to 2 pi, okay? Now, if I say I did 3 sine of x, so 3 sine of x, okay? So again, you see how now the graph, the wave is still there, right? We still have one cycle from 0 to 2 pi, right? But now my amplitude is going to be 3 because I'm going up to positive 3 and down to negative 3. Okay, so it's pretty, whatever the number is in front of the sine or cosine, that's what you're going to represent your amplitude. So I'll show you what cosine looks like. So cosine of x, okay, looks very similar to what we did on notability, right? So you have high axis, low axis, high, right? So now if I do, say, 2 cosine of x, right? See how the high and the low points, again, now are going to go up to 2 and down to negative 2, okay? So the x values aren't changing, but the y values are, okay? And then we'll do one more. So you got 3 cosine of x, right? Going up to positive 3, down to negative 3, okay? So for each of them, again, your amplitude, again, represents the number, right? So my amplitude here would be 2. Amplitude here would be 4. Here my amplitude would be 1/2. So this one's only going to go down to 1/2 and negative 1/2. And then the negative will just be a reflection, which we'll talk about in another lesson. And then this one, amplitude is 3, which also has a reflection. Okay? So finding amplitude is pretty straightforward. All right, now the last thing that we'll talk about for this one is what the b term represents. Okay, now the b term is going to be the number that's going to go in front of x. Okay, now the b term tells us the number of cycles in 2 pi. All right, it is the number of cycles in 2 pi. Okay, and that'll help you figure out what your period is. Okay. Now to figure that out, how many cycles you have, you take what typically you have as 1 cycle, which is 2 pi, okay, and you're just going to divide it by the b term. Okay, so we're going to use this quite frequently as we're working these out. Okay, so you're always going to take 2 pi divided by the b term, and that'll tell you how many cycles you have in between 0 and 2 pi. Okay, so if I'm going to go back to Desmos now, get rid of these guys. So what I'm going to do, I'm going to go back to sine of x. Okay, now what I'm going to do, I'm going to do sine of 2x. Okay, now if you guys look at the graph, right, it looks a little bit different. All right, so instead of vertically stretching it, we're horizontally shrinking it here, right? Now the b term here is 2, right? B equals 2 here because it's 2x. Okay, now if you look at, if I'm going to turn sine of x off, you see in between 0 and 2 pi how many times that the cycle repeats itself? So if I start at 0 and I go to 2 pi, right, I have axis, high, axis, low, axis, right? That's 1 cycle. And then high, axis, low, axis. That's another cycle, right? So I have 2 cycles between 0 and 2 pi, right? That again comes from the b term being 2, all right? So it just shrinks the graph horizontally, all right? Now if I did like another one, say sine of 4x, all right, I'm going to turn sine of 2x off. Okay, see how now the wavelengths are becoming much shorter, right? So between 0 and 2 pi, right, I have 1, that's 1 cycle, 2, 3, 4, right? You got 4 cycles as you go from 0 to 2 pi, right? And again, that comes from just taking the b term here, which is 4, and dividing it by 2 pi. All right, so if I go back to the notes now, all right, so if I just go through a couple of these, right, so I have sine of 2x, right? So I know that the b term here is 2, right? So the period is going to be 2 pi divided by 2, right? It's always 2 pi divided by the b term. So I'm going to do 2 pi divided by 2, which is 1 pi, all right? So the period here, right, the length that it takes for the cycle to complete is 1 pi, okay? If I did sine of, say, 6x, right, b here is 6, and the period, I'm going to do 2 pi divided by 6, or pi over 3. All right, so this graph, sine of 6x, takes a length of pi over 3 to finish off its cycle. And it's going to have 6 cycles between 0 and 2 pi. All right, now it works the same thing for cosine. So if I did cosine, say, of, say 10x, right? B in this case is going to be 10, and the period is going to be 2 pi over 10, or pi over 5. All right. Now to kind of put it all together, say we had 4 cosine of 8x. Okay, so I know that the a term here, a would be 4. All right, so my amplitude is 4. So my highest value would be 4, and my lowest value would be negative 4. So highest is 4, and then lowest would be negative 4. And then the b term is 8. All right, so my period would be 2 pi divided by 8, or pi over 4. Okay, so those are definitely two big things that you guys want to make sure you figure out first when we start graphing these, because everything's kind of based off of those two things: amplitude and period. Okay, so in the next lesson we'll start graphing some of these with the transformations in them.